are you going to give? How will you define this one? Why the boiling point, that is the lowering, no, it is what
So that is
relative lowering vapor
that
pressure.
is the lowering of vapor pressure depends only on the concentration of the solid particle independent of their identity.
So that is vapor pressure is going to lower. Is this
Yes,
answer?
yes.
On what factor it is going to depend?
So depend on the concentration on of the solute particles.
Which concentration terms? Which concentration term?
Partial pressure.
Partial pressure. Partial pressure is not a concentration term. You think some other one, like molality, mole fraction, some other type.
Sir, this mole fraction.
Mole fraction. Okay. Have you gone through this year question paper?
This year means, sir, I do not have, I think.
Acha. Okay. Now, today we are going to study the elevation in boiling point. Elevation in boiling point. What do you mean by elevation?
Elevation means
Elevation in boiling point. What do you mean by this one?
increase.
Increase. So, what is happening? See, here is what is there. This is the pure solvent. This is the pure solvent. And this is the solution. Solution. Okay. And solution is what is there? Solid in liquid. Solid in liquid. This solution is what? Solid in liquid. And you got to know that is solid vapor pressure is what is there? Solid vapor pressure. There is no vapor pressure of solid. But pure, this is pure, this liquid solvent. This is what? Liquid solvent. This is there. Now, which will have more vapor pressure? Which will have more vapor pressure?
Sir, liquid solid in liquid solvent will have more vapor pressure.
Why?
Sir, because there the surface is not being occupied not by any other solid particles, but sir, in solid the surface will be occupied means that the capacity for the evaporation will be less.
What again can you say? Can you say the same?
Sir, I am telling that in case of this one, sir, when solids are present in the liquid, so that case there will be the reduction in the surface area through which the evaporation can occur. But in liquid solvent, the evaporation can occur faster.
Okay, very good, very good. Acha, this is if suppose I will talking about solid and liquid, what will happen here? This more vapor pressure, more vapor pressure. More vapor pressure means it will boil at high temperature or less temperature. More vapor pressure means boil at high temperature or less temperature.
Sir, more vapor pressure means boil at less temperature.
That is boil at low temperature. Low temperature. That is very good. Now here you got to know there are the many type of the solid particle are there, and solid particle do not vaporize, that you already knows. Okay. So when you are adding the non-volatile solute in it, so what will happen? That is vapor pressure, low vapor pressure, low vapor pressure. Yes. So boil at high temperature or less temperature? Boil at what? Boil at
Sir,
low
boil
temperature or high temperature?
high temperature.
High temperature. So already you know most of the things you are knowing. Okay. So here see, when non-volatile solute, non-volatile solute is added to pure solvent, then the boiling point, of solution increases. boiling point of solution increases. This is. Or you can write boiling point of solvent in solution increases. Either you say boiling point of solution increases or boiling point of solvent in solution increases. How much if I will consider delta TB? So it will be there TB minus TB naught. TB minus TB naught. What do you mean by this one? This is TB naught is boiling point of pure solvent. Boiling point of pure solvent. This is boiling point of pure solvent. This is what is there? Boiling point of solution. Boiling point of solution. And this is what? Elevation in boiling point. Elevation in boiling point. Elevation in boiling point. Can you understand this one?
Yes, sir. Yes.
This is not very tough. This is easy one. Little bit you need to focus. Already you told this all the things. I have given the statement that if here the solute solvent both are there na, in the second figure. So what is there? You need to, because it become the low vapor pressure. So you need to heat more. So boiling point of solution increases, or in other word, boiling point of solvent in solution increases. So what to get the increase in boiling point, elevation in boiling point. So what we have to do? The higher will be what the boiling point of solution and lower will be boiling point of pure solvent. So you will get the elevation in boiling point from here by this formula. Can you?
Yes,
Can
sir.
you?
Yes, sir.
Can I erase?
Yes, sir.
Okay. Now, the elevation in boiling point, elevation in boiling point is a colligative properties. Why it is colligative properties? As it depends on number of solute particle only, and not on its nature, and not on its nature. And it is means elevation in boiling point. It is proportional to proportional to molality, MOLALITY. This is molality. Now here is delta TB proportional to what we are writing, molality. This one. This is MOLALITY, molality. So delta TB is equal to KB into M. Now this is molal elevation constant. Molal elevation, ELEVATION. Molal elevation constant. Also called ebullioscopic constant, EBULIOSCO, ebullioscopic constant. Okay. Now, what is the molality if you talk about delta TB is equal to KB into molality, number of moles of solute. Here is mass of solvent in kg. Mass of solvent going to be in kg. Now, here we are putting this one more. So here is delta TB. Little bit you can go little bit upper part. Okay. So here we are writing this thing. So here delta TB is equal to, it is KB into number of moles of solute. What we can write? W2 upon M2 divided by W1 upon, this is 1000 because this is in the gram. This is the solute. solute. And this is going to be solvent, mass of solvent in kg. So we are dividing this one. So delta TB is equal to Kb into what it will be? W2 into 1000 divided by M2 into W1. Can you understand this formula?
Yes, sir.
This is the given mass of what? Solute. This is given mass. M2, molar mass of going to be solute, molar mass of solute. W1, gram mass of solvent. Is it okay?
Yes, sir. So keep
Can I-
this slide for 1 minute.
Now ultimately your that is mic started working, right? We tried so many times.
Sir, generally every day it is okay only. Don't know what happened today.
No, network may be not connecting. Network issue sometime happen.
Not network issue, sir. I could hear you, but you could not hear me. This is not
Okay, not a problem. Maybe
molality. Yeah, just 1 second. Sir, what is the meaning? Check. Okay.
what you are talking about?
No, sir. Got. I got it.
Done.
No, sir. No, sir. This last part only I'm writing. So done.
Done, na? Now, unit of molar elevation constant, ELEVA TION, a molar elevation constant. So delta TB is equal to KB into small m. So KB is equal to delta TB upon small m. Delta TB is temperature, Kelvin, and molality is mole kg inverse. So what will be there? Kelvin, mole in Kelvin, kg. Kelvin, kg, mole inverse. This is the kb. And delta TB elevation in boiling point, it will be Kelvin. Unit of elevation in boiling point. Elevation in boiling point. So this is what? Kelvin. Can you understand?
Yes.
Okay. Can I erase?
No, sir. Writing.
Can I?
No, sir. 1 second. Done.
Okay. So what we are going to do, we are sharing the NCERT, going to see the line by line what we can do. Okay. Here see elevation in boiling point. So what is there? We have learned in unit 5:11 that the vapor pressure of liquid increases with increase in temperature. Is it okay? Vapor, obviously, if you are boiling the liquid, the vapor will increase. So that is vapor pressure of liquid increases with increase in temperature. Is it okay?
Yes, sir.
Now, it boil at the temperature at which the vapor pressure is equal to atmospheric pressure. So, if the here is what is there, this is atmospheric pressure is there ATM, and downside what is there vapor pressure. So, what will happen if both the things become equal? If the equilibrium is being set between the atmospheric pressure and vapor pressure, so it is what is boil. It get boil. That is what That is what that temperature is called boiling point. Boiling point. So boiling point is what is, that is when the vapor pressure of liquid become equal to atmospheric pressure, that temperature is called boiling point. So what the point here they have mentioned, if you see NCERT book, it boil at the temperature at which its vapor is equal to atmospheric pressure. Can't you get?
Yes, sir.
For example, water boil at 273.15, that is 100 degrees Celsius, because at this temperature, vapor pressure of water is 1.013 bar, that is 1 atmosphere. So why it is boiling? That is if you 373.1 Kelvin or equal to 100 degree is equal to what? It is going to be 1 bar or 1 atm, 1 atm. So in this case, this is the 1 atm equal to what? Atmospheric pressure is the same, also 1 atmosphere. So that is why it boil. Okay. Now the boiling point become how much? 100 degrees C. We have also learned in the last section the vapor pressure of the solvent decreases in the presence of non-volatile solute. Can you see this one? Can you understand this statement?
Yes, sir. You only explained the last.
Now, in figure 2.7, depict the variation of vapor pressure of the pure solvent solution as fraction of temperature. Depict the variation of vapor pressure of the pure solvent and solution as the mole fraction. So, vapor pressure, variation of vapor pressure, that is relative lowering vapor pressure was the fraction. This is the, no, depending on the mole fraction. For example, the vapor pressure of aqueous solution of sucrose is less than 1.013 bar at 373.15 Kelvin. In order to make this solution boil, its vapor pressure must be increased to how much? 1.013 bar by raising the temperature above the boiling temperature of the pure solvent. Thus, the boiling point of solution is always higher than the boiling point of the pure solvent in the solution. So I explain on the there where you can go see what I explain here. See here, the non-volatile solute, when non-volatile solute is added to pure solvent, the boiling point of solution increases, or boiling point of solvent in solution
Then the vapor
increases.
pressure will decrease means the boiling should be increasing, otherwise not will be there. The
That is what
boiling
you are
point
saying,
increasing.
correct one. But statement must be clear, na. That is why. See here, again you read. What the point here they are writing, that is, by raising the temperature above the boiling temperature of pure solvent, thus the boiling point of solution is always higher than the boiling point of pure solvent in which solution is prepared. This one point I want to
Yes, sir.
explain.
Because whenever you are making a solution, so that means you must be adding some solute in the solvent. So that solute particle is covering the surface area. So that you have lesser vapor pressure compared to that. So you have
Thank
more
you,
boiling
thank you,
point.
thank you, thank you, thank you. So here you see, similar to lowering of the vapor pressure, the elevation of the boiling point also depend on the number of solute molecule rather than the nature. This point also I explained. Similarly, you can see, lowering vapor pressure, RLVP we have done. The elevation of boiling point also depend on number of solute molecule rather than nature. Means it become the colligative properties. Yes or no?
Yes, sir.
Here a solution of 1 mole sucrose in 100 gram of water holds at 373.52 Kelvin at 1 atmospheric pressure. So it has how much? That is increase one. It should be 373.15. This is the boiling point of water. But here, if you are adding the 1 mole of sucrose in the 100 gram water, the boiling point increase, can you see? 373.52. Can you see?
Yes, sir.
So BP of solution and this is the pure solvent. So increasing. Now in the diagram, you can see this one. Okay, this diagram you see, little bit diagram is problematic one because you can't see very clearly. This you can see the solvent line and this is solution line. This is the temperature is going. Okay. And here is
So
the
you
pressure is
can
there.
zoom the diagram a bit because not visible
If I
clearly.
will zoom now, it is zooming too large. So it is again problem only. Okay, see. So this is the solvent boiling at the low temperature. Can you see? This is
Yes,
this is the temperature line. So boiling at low temperature, yes or no?
yes,
And solution is boiling at high temperature. And this difference, temperature difference is called elevation in boiling point. So here, let's TB not be the boiling point of pure solvent. This one is there. It will boil at low temperature. And TB is boiling point of solution. It will boil at high temperature this side. The increase in the boiling point is what will be there. Delta TB is equal to TB minus TB naught, known as elevation in boiling point or elevation of boiling point. Can't you understand this?
yes, sir.
Thank you very much. Now, experiment have shown that dilute solution, the elevation of boiling point delta TB is directly proportional to molar concentration of solute in the solution. What is molar concentration, Sanjay?
Molar concentration is the amount of solvent by the number of moles of the solvent divided by the total number of kilograms of the solute.
Number of solute or solvent?
No, sorry, sir. Number of solute divided by
Oh,
number total.
hmm. So this is the delta TB is proportional to molality. Delta TB is equal to kV into M. That we have done already. Here M is molality, the number of moles of solute dissolving in 1 kg of solvent, and the constant temperature. Kb is called boiling elevation constant. Boiling elevation constant. Molar elevation constant. Ebuloscopic constant. EBU The unit of Kb is Kelvin kg per mole. The same we have done. Unit of Kb.
Yes.
Value of Kb for some common solvent are given in table 2.3. If W2 gram of solute, molar mass M2 is dissolved in W1 gram of solvent, the molality M, the solution is given by expression. So that already we have done this one. Just I'm showing you for the proof one, right? This we have done already. Yes or no?
Yes, sir.
This is molality 1. So molality 1 you can put in this equation delta TB is equal to Kb into M. So this at the place of M you are putting this value. So you are getting this one that we have done also. And if you want to calculate M2, this will be okay. Thus, in order to determine M2, molar mass of solute known, mass of solute is known, mass of solvent is taken, delta TB determined experimentally, known as solvent, whose Kb value is known. So this is what the problem. Now, here the question is there. We are starting the question example number 2.7. 18 gram glucose, that is W2 is equal to 18 gram. C6H12O6, that is M2 is equal to how much? Glucose, 180 gram. Dissolve in 1 kg of water. Dissolve in 1 kg. W1 is equal to 1 kg. In saucepan. At what temperature will boil water? Will water boil? At 1.013 bar. Kb for water is 0.52 Kelvin kg per mole. So 0.52. What formula you are going to use? Delta TB is equal to Kb into M. So delta TB is equal to what will be there? Kb into W2 into
Yes.
1000 divided by M2 into W1. This one is the 1 kg is equal to 1000 gram. Yes or no? So this is the gram one. So
Yes,
KB
sir.
0.52 multiply by 18 multiply by 1000 divided by 180 multiply by going to be 1000. Cancel out. This is again cancel out. So 0.052 Kelvin. This is coming. Are you sure? Will it come? Delta TB is equal to TB minus TB naught. Okay. So what they are asking, boiling point of what? They are asking at what temperature will water boil? At what temperature will water boil? Okay. So when, that is what they are talking about, boiling point of solution only, na? After dissolving. See, TB not already you know, boiling point of water you know how much? It is 373.15. Yes or no? Or 100 degrees C.
Yes.
This already we know.
Yes.
So what we can do here? Delta
It's
TB already we got
73.1.
to know. 0.052 is equal to TB they are asking minus TB not we know 373.15. So what will be there? TB is equal to, it will increase 0.052 373.15. You can add how can we add this one? This one. I am adding 373.15 0. Point down point 052. So we are adding this is 2 0 2 3 7 3 373.202. TB is equal to 373.202. Can you understand this?
Yes, sir.
Yes, sir. So you check the answer here they have given.
Sir, once again, show the slide, sir. Once again, I could not copy the whole thing.
This is the NCERT problem. Hey God. Done.
Done, sir. Done.
Okay, let me check the answer also in the book. The page number 40. Can you check the answer in your book? Do you have the book?
Yes, sir. I have, sir. What is the question number? Here?
Problem number, example number 2.7. Example number 2.7. Did you find?
Yes, sir. 373.202.
So understood now?
Yes, sir.
Okay, very good. Now the next question you see. This one. 19. Is the answer given or what? Yeah. Okay. Question number 19. A solution containing 12.5 gram W2 is equal to 12.5 gram. This is non-electrolyte, means it is not going to ionize substance in 175 gram water. So W1 is equal to 175 gram. What is there? This 175 gram is, this is the water. Gave a boiling point elevation of 0.70 K. So delta TB is equal to 0.70 Kelvin. Calculate the molar mass of the substance, that is M2 they are asking. Molar mass, elevation in boiling point of water, Kb they have given how much? 0.52 Kelvin, kg per mole. So this is very simple. Let me try this one. Okay, I am doing here. Delta TB is equal to Kb into small m. So delta TB is equal to KB into W2 into 1000 divided by M2 into W1. Okay. Now M2, if you are writing M2 is equal to KB into W2 into 1000 divided by what will be there? Can you tell me what will be divided by?
M2 into W1. M2 not
Delta
given
TB into
and W1 is
W1.
175.
So now here is KB value 0.52, W2 12.5 multiply by 1000 divided by delta TB they have given 0.70 multiply by W1 175. Okay.
Yes.
So 0.52 multiply by 12.5 multiply by 1000 divided by 0.70 divided by 175. 53.06 is coming. 53.06. This is gram per mole. This is the M2. Can't you understand this question?
Yes.
Can I erase this question?
Yes, sir.
Did you note the answer, this one?
Yes, sir. I noted.
What? Okay.
Sir, I noted.
So check the answer whether it is correct or not. How much you got the answer?
53 only.
53 only. Round figure will be 53 only. So this is our required answer. Understood now?
Yes, sir.
Okay, now solve the next one. Oh my God, this is asked, but very big questions. Can you do this one or should I do?
So you do. Let me see.
Okay. So you are always saying to me to do. Okay, not a problem. See, explain as to why there is rise in the boiling point when non-volatile solid dissolve in liquid. This one you have to explain because vapor pressure decreases, so boiling point increases. Okay. Now, how much gram of the non-electrolyte was dissolving? 0.92. So W2 is equal to 0.90 gram of non-electrolyte dissolved in 87.90 gram. So W1 is equal to how much is there? 87.9 gram of benzene. This raised the boiling point of benzene by 0.23 degrees C. So delta TB is equal to 0.23 degrees C. Raise elevation in boiling point of benzene. Now, what is if molecular mass of non-electrolyte is 103? M2 they are talking about 103 gram per. Calculate the molar elevation constant of benzene. Molar means they are asking Kb, right? Yes or
Yes.
no?
Yes, sir.
So what formula can we use? Delta TB is equal to Kb into M. So delta TB is equal to Kb into W2 into 1000 divided by M2 into W1. So what will be their delta TB value? Delta TB value 0.23 degrees C. Okay. You can do in the Kelvin also, but let it be in the degree C because it is the difference now. So if it is the difference, it should come C. It is okay. It is degree C only they have given now. Check in the book. Degree, let it be in the degree C. Why to change? Okay, because that answer will come in the degree C. KB they are asking. W2 they have given. W2 is 0.90. Multiply by 1000 is there. M2 they are saying 103. W1 they are talking about 87.9. So KB is equal to 0.23 multiplied by 103 multiplied by 87.9 divided by 0.90 multiplied by 1000. Now you try to solve this one. I am doing this one here. So 0.23 multiplied by 103 multiplied by 87.9. If you are dividing this 1.90, this gives this one divided by 1000, 2.31. This is 2.31 Kelvin kg mole. No,
Sir,
degree
today
C.
you can complete this chapter totally. So then next class we will do the exercises and the
I am
syntax.
human or robot, you are thinking? I am teaching you now. How can I
No,
complete it?
no, sir, if it is possible or not, that only I'm asking.
Impossible. It will take time. Yesterday we did not study your practical exam. Also, I got tired.
Hmm.
How is it possible? We studying most possible as much as possible now.
Sir, I'm just asking, sir. Don't take it like that.
No, Calvin. I am also thinking to finish only. You don't think like that I am teaching you for the money purpose only. Okay. That's not the issue. Just I too want to finish. That you keep in mind. I too want to. You study today up to 12 o'clock, 11 o'clock. You study there is time with me. What maximum I can do, that I am doing. So this one is the unit you see, 2.31 degree C kg mole inverse. Now, understood this one.
This one understood.
Now check the answers. What is there? Oh yeah. What unit they are writing the answers? This one is the wrong answer they have done in the question, I think. See? Unit they are writing what? The Kelvin mole inverse. Molar inverse. That is okay. But how they are putting the Kelvin? Because they have done in the degree C now. When non-volatile dissolve in the, see the definition, when non-volatile solid dissolve in the liquid, a point of liquid surface is occupied by solute particle. The effective area of vaporization of the liquid decreases. The vapor pressure of liquid decreases, hence the boiling point increases. Are you getting this one statement?
Getting, sir, but
Getting, but what problem?
no understanding, sir. But still, this is not coming, sir. Correct answer not coming.
Correct answer. What is the value is same now? 2.5 something coming. 2.31.
But our came 2.31 degree centigrade kg per mole. Here they're coming Kelvin per mole.
What it is there? See, delta TB is what is there? Whether you take in the Kelvin or you take in the degree C. Change is always same. Change is always same. Change is always same. So you converted in Kelvin, suppose how I am doing. It is there, suppose 100 degree C minus 99 degree C. How much it will come? 1 degree C. 1 degree C. Now, so if I will go, if I will go in the Kelvin, suppose it is 373 Kelvin minus 372 Kelvin. So how much will come? 1 Kelvin. So temperature difference is same. Whether you are putting in the Kelvin or the degree C, difference is 1. Difference is 1. Okay. Whatever the unit it may be, whether in the Kelvin, whether in the degree C, difference is same. Now, here they did the in the Kelvin. Otherwise, in the question itself, you can write in the Kelvin because it is the temp delta TB. Change, always keep in mind, change is always same, whether it is degree C or the Kelvin. That you need to slowly you will learn this concept. You have to accept, otherwise there is no other way to accept other than accepting. Okay, now you solve this. Now I think that same question is what this is. No,
Let me check
it's
some.
it is same. Leave it. 2 point. Here there's Kelvin kg per mole they have mentioned. Now they have mentioned Kelvin kg per mole. Now you see here anything if they wrote. If anything they wrote. Delta TB they are placing now 25 degrees C. Equal to that is change is always same somewhere. That is what you need to understand. Somewhere you need to think now after be relaxed and then think that why sir is saying that is degree C, change in degree and change in Kelvin will be same. Why? That you need to think. Here you see this is. I'm giving you multiple questions. Now we are going to do the problems only. What is there? That is this one we have done. I have many problem actually. What is this one? Huh. Try it. Can you try it? What should I do?
Let me see, sir. If I am not able to do, then you do.
Okay, you read, otherwise you tell me. I will do. No problem.
Sir, I think I need to practice this type of problem bit more because
Okay, then
it's
I
very
should I
clear.
do? Then I am doing now. Then I am doing.
Okay.
Can I? Okay. The boiling point of benzene is how much? 353.23 Kelvin. So it is not in the solution now, pure benzene. So this is TB naught. TB naught is equal to 353.23 Kelvin. Okay, now when 1.80 gram of non-volatile solid was dissolved in 90 gram of benzene. So W2, how much they are talking? 1.80 gram of non-volatile solute dissolved in 90 gram of benzene. W1 is 90 gram of benzene. The boiling point is raised to 354.11 Kelvin. So TB is equal to 354.11 Kelvin. Calculate the molar mass of solute. M2 they are asking. Kb for benzene they have given how much? 2.53. Just now we have calculated Kelvin kg mole inverse. Now M2 they are asking. So let me do. So no, this is the formula. TB is equal to Kb into small m molality. Delta TB is equal to, firstly I'm calculating delta TB. So TB minus TB naught. TB is equal to how much there? 354.11 minus 353.23. Can you, how much is coming the difference? Can you tell me the difference? 354.11 minus 353.23, 0.88, 0.88 Kelvin. Now, you are putting the formula, this formula, delta TB is equal to Kb into W2 into 1000 divided by M2 into W1. Or you can write M2 is equal to Kb into W2 into 1000 divided by delta TB into W1. So what is the value of Kb? Already given 2.53. W2 1.80 multiply by 1000, very simple, divided by delta TB, just now we have calculated 0.88 multiply by W1 90 gram. Now you can try it. So what is 2.53 multiply by 1.80 multiply by 1000? It is coming 4554 divided by, if you are talking about 90 multiply by 0.88. So 79.2. So what you can do, 4554 divided by 79 point, what is there here? 2 is equal to 57.5. 57.5 gram per mole. Can you understand this? Look.
Yes, sir.
Now, see the answer here. There is solve answer also there. How much there? 57.5 equal to 58 U.
Sir,
Can't
you
you
bring the solution slide once again. Solution slide.
this one? This one.
Sir, keep this for 1 minute only.
Don't write the question. I will share you the question. Not a issue. This one.
No, sir, not writing the question. Sir, I missed some part of the answer. That is why.
That is not a problem.
Sir, from this chapter, how much marks is coming in the board exams?
Minimum 7 marks. And maximum is anything is possible.
Done.
Okay, very good. Now we are going to going this answer. Have you verified the answer now? Here we have verified this one. 58 U. Yes, no?
Yes, yes.
Okay. Now we are seeing this one. Boiling point of water is 75 mmHg. How much sucrose will be added to 500 gram of water such that it boil at 100 degrees C? Given how much? Given Kb is equal to 0.52. This is asked the exam. It is good question actually. If you see this question, you won't understand. You won't get anything from this one. So boiling point of water at 750 mmHg they have given. So actually TB naught they have given 99.63. This is degree C. How much sucrose is added to W2 they are asking. Sucrose W2 they are asking. What is the M2 of sucrose? Do you know molar mass of sucrose? C12H22O11. How much is there? Can you tell me?
C12
Something.
H22 11.
341 something it will come. We will calculate. Now W2 they are asking. M2 they have given. W1 they have given how much? 500 gram of
So I
water.
think 342 will be there for see this one.
Are you sure now? 342.
Yes, sir.
Sure.
342.
It must not get okay. And KB also given KB 0.52. See, by seeing this question, it is very difficult to predict what they are asking. Now, after this one, you will be able to. So delta TB is equal to what is there? KB into M. This is there. You can simplify delta TB is equal to KB into W2 into this is going to be 1000 divided by M2 into W1. What they are asking? W2 actually they are asking. So this is going to be, first of all, you can calculate delta TB. So I am calculating delta TB is equal to what is there? TB minus TB naught. TB minus TB naught. Now you see TB somewhere they have given. TB they have given what? How much sucrose to be added to 500 gram water such that it boil at 100 degrees C. So this is 100 minus 99.63. Okay. So you see 100 minus 99.63. 0.37. 0.37. So now what I am doing here, that is I require W2. So W2 I am writing here, that is delta TB multiplied by M2 into W1 divided by what is W2 into, this is going to be 1000. Now here delta TB already we have calculated 0.37. M2 M2, you are saying that is 342 will come. W1, they have given 500 gram. 500 divided by W2. W2, no. God, what I did here. W2, they are asking somewhere. Wait. Give me 1 minute, please. So W2 is equal to delta TB into M2 into W1 divided by KB into 1000. This will come only now. Okay. So delta TB 0.37 multiply by M2 342 W1, that is 500 gram. KB they have given here somewhere 0.52 multiply by 1000. So this is going to be 2 times. Okay. Now let me, it is divisible by the way. 0.37 multiply by 0.37 multiply by 342. So it is coming how much? It is coming 126.54 divided by 0.52 multiplied by 2. This is 1.04. So how much is coming, student? 126.54 divided by 1.04. So it is coming 121.63 gram. This is the W2. So if you are adding the 121.63 gram, so its boiling point will increase from 99.63 to 100 degrees C.
Yes.
Can you now see the answer here?
No, sir, one second, sir, not done still.
Firstly, you
Last
check the answer. Answer, can you check? 121.63.
1267.
121.67. Now see how much we are getting.
121.63. Same only, sir, same. Same only.
No. I wrote here wrong, yeah. 126.7 is there. I wrote wrong. You can use the calculator. Can you use the calculator? Verify this one.
Checking,
Do you have?
sir.
Check
Yeah,
this one.
I have.
You check this one.
Checking, sir. 0.37 into 342 into this one 500. You see? 6.
How much is coming?
Doing, sir.
Use the calculator, please. Use the calculator. Time is not there.
Using 63270, and here we have 0.52 into 100. That's 52. That's 552. Then 66.
Here you verify this line only now. Why you are doing all this one only now? You do.
This is only coming, sir. 121.67.
That is what the here also given same now. So did you get it? This is it okay?
Yes, sir, I got it.
Oh, good. See this one. So at what temperature will water boil? They are asking TB. TB they are asking.
TB they are asking. That means, sir, TB not will be given, del TB will also be given.
TB not will not be given. Now for the water, it is how much? 373.15 Kelvin. Okay.
I mean that is given only, na, because we know that one.
W2 they have given 18 gram. Okay. Glucose is there. M2 you already know 180 gram per mole. Okay. And here is the W1 given how much? 1 kg. 1 kg means 1000 gram. This is there. Okay. So now delta TB is equal to what it will be there. This is going to be TB, KB. This is going to be KB into W2
Maybe
into
given.
1. KB is given. Divided by what? M2 into W1. So KB is 0.52. W2 they have given 18. Multiply by 1000. Okay, divided by M2. This is going to be 180. And if you are 1 kg means 1000 gram. This gone cancel out. This gone cancel out. Acha, I think we have done this problem.
No,
This is
sir, not.
there. Okay, not a problem. So delta TB is equal to what is there? TB not TB minus TB not. So delta TB, if you go 0.52 is there. 0.052. TB there.
0.05.
Here is 373.15. This is there. So TB is equal to 373.15 plus 0.052. You can add somewhere 373.15. Decimal down decimal 052. This is 0.202. What will be here? 373.202 Kelvin. So here is water will be boiling now in the solution. It is increased 202. So getting this one.
Yes, sir, I also did same answer.
Here you see the solution will be there. How much is coming? 373.202. Okay, see the next question. This one I think we have done. Dissolve in 90 gram of benzene. Boiling point 353. 354.11. Calculate the molar mass absolute. Can you do this one? This is very easy. Calculate the molar mass absolute. We have done this one. This problem we have done. Okay, 23.
Yes, I see. Yes.
Next one you see. Here you see. The boiling point of benzene is this one, non-volatile. So dissolve 90 gram, raise to temperature. This one. This one is also this type problem we have done. This is, see, the CBSE question. What is there? A solution of 3.8 gram sulfur in 100 gram of CS2. Boiling point 46.3. Boil at 46.66. What is the formula of sulfur molecule in the solution? That is what. So M2 is getting 252. So this is their 252. Yes, it. I am doing this one. You try to see this one. Okay, 24. So what is our solution? 3.8 gram of sulfur. W2 is there 3.8 gram. In 100 gram of CS2. W1 is 100 gram. So M2 is equal to, they are asking, I think. Boiling point, they are talking. Boiling point, how much is there? TB not sulfur, 46.3 is there, degree C. And when you are adding, so boiling point of solution become 46.66 degree C. What is the formula of the sulfur molecule? Okay. So how can you do this one? Let us try to do. First one, delta TB you calculate. Delta TB means TB not, TB minus TB not. So TB is what is 46.66 minus 46.3. 0. So this is 6. 0.36 Kelvin it will come. Kelvin or degree C, temperature difference is same. So now you plug the value here. What is there? Delta TB is equal to KB into W2 into, too much sound is coming somewhere. M2 into,
Sir, I don't know. Here no sound is there.
so delta TB, we have got, okay, M2 we required. So M2 is equal to KB into W2 into 1000 divided by delta TB into W1. So what is the KB they have given here? 2.40. 2.40 multiply by W2. W2 3.8 gram multiply by 1000 divided by delta TB 0.36. W1 if you see here 100 gram. So if you are dividing this one, 20 will be cancelled out. So 2.40 multiply by 3.8 divided by 0.36. Okay, let me find out the value here. Please wait. 2.42, 2.40 actually, multiply by 3.8 divided by 0.36. It is coming something 25.33. Here any value is there in the other form unit or what? Gram. This one okay. What is the formula of molecular? The atomic mass of sulfur is 32. Okay. $253 is coming, Sonay. M2. Here we have done something more. 253 should come. Whatever the answer we are getting, this is not the correct one. 253. Decimal sign we are missing somewhere. Why decimal sign? 2020 cancel out. 10 is left here behind now. So it will be the here 8 only. Okay, this place. What will be there here? Without decimal will be there. So if you are solving this one, so what is coming? 253. You can see multiply. This is the 253.3. This one 253.3. Now here they are saying formula. Formula, how can you do? Formula. So that is we have done molecular mass is equal to N into empirical mass. N into empirical mass. This formula. So N is equal to mm upon EM. Up now molecular mass is how much we are getting? 253.3 divided by empirical mass of sulfur is 32. So if you divide this by 32, so it is coming 7.9. 7.9 is equal to 8. So what is now? Molecular formula is equal to En into empirical formula. So N is value 8. What is the N value is? How much coming? N value is coming 8. Empirical formula is S. So it is coming as 8. This is the molecular formula. This type of problem will come in the NEET exam, not in the board exam. Little bit it is tougher. So here you see this one. What they have done, they got this one by similar formula. Then the same formula we use here. So they are getting 8. So the sulfur is S8. Now, these are the practice question I'm giving you. They want to, this all you can try. These are the CBSE board question asked in the CBSE exam. These are 3, 4. There are many more question 5. Now you can go down. You will keep on getting 6. You will get the n number of question are there. Okay. And all the answer I have given downside, you can keep on solving. Got it? Tomorrow we will study the depression in freezing point. Tomorrow you are saying
Sir,
that
tomorrow I will be outside.
okay. Tomorrow you will be outside. Then how can you complete the syllabus? You are very eager to finish early and you only
Sir, I am
missing.
going home, sir. Going to my hometown, sir.
No, yesterday you was, but yesterday you said that is you will be doing the practical work, so you delayed the class. Then how can you finish on
Sir,
according to your?
actually, problem is, sir, after the whole year, what that in our school, what is doing, sir, in our school told that full chemistry and biology complete all the practicals in one day only. So, sir, that took the whole day, na, because chemistry 6 practicals had to do, biology about 8. So, sir, that took a lot of time because practical copy should be made like that only. So, sir, that is why it took the time, sir.
Not a problem for me. Okay, so we'll connect to day after tomorrow then. Whenever you return back, you inform me, right?
Sure, sir.
Okay. I will share you this problem. You go and solve the problem.